3. Securing normal user accounts. Managing users is one of the more challenging aspects of IT administration. You need to make sure that users can always access their stuff and that they can perform the required tasks to do their jobs. You also need to ensure that user stuff is always secure from unauthorized users. In this chapter, we'll look at how to lock down user accounts and user credentials to protect them from attackers and snoopers. We'll wrap up by taking a brief look at a few centralized user management systems, locking down users' home directories, enforcing strong password criteria, setting and enforcing password and account expiration, preventing brute force password attacks, locking user accounts, setting up security planners, detecting compromised passwords, understanding central user management systems. Locking down users' home directories the Red Hat way. This is another area where different Linux distro families do business differently from each other. As we shall see, each distro family comes with different default security settings for users' home directories. Our security administrator who oversees a mixed environment of different Linux distros will need to take this into account. Traditionally, Red Hat Enterprise Linux and all of its offspring, such as CentOS and Normal Linux, have had better out-of-the-box security than any other family or Linux distros. This makes it quicker and more easier to harden Red Hat systems because much of the work has already been done. One thing that's already been done for us is locking down users' home directories. By default, the user add utility on Red Hat type systems creates user home directories with a permissions setting of 700. This means that only the user who owns the home directory can access it. All of the normal users are logged out. We can see why by looking at /etc/login.defs file. On your CentOS 7 virtual machine, scroll down toward the bottom of the file and you'll see this. create_home, yes, umask 077. In the login.def files of a Red Hat Enterprise Linux 8 or ReHeld 9 type distro, such as Normal Linux, you'll see that the umask is set full wide open permissions, which seems a bit strange. Here's what that looks like. umask 022. But a few lines below that, you'll see a brand new directive that we never had before, which looks like this. home_mode 0700. So even though the umask is wide open, new user home directories still get properly logged down. The login.def files is one of the two files where the default settings for user add are configured. Either the umask line or the home mode line is what determines the permissions values on home directories as they get created. Red Hat type distros have them configured to remove all permissions from the group and others. Either the home_mode line or the umask line is in the logs.def file for all Linux distros, but until recently, Red Hat type distros have been the only ones that have had them set to such a restricted value by default. Most non-Red Hat distros usually had a umask value of 022, which creates home directories with a permissions value of 755. This allows everybody to enter everybody else's home directories and access each other's files, locking down users' home directories the Debian Ubuntu way. Debian and its offspring, such as Ubuntu, have two user creation utilities, user add user. Let's look at both of them. User add on Debian Ubuntu. The user add utility is there, but Debian and Ubuntu don't come with handy pre-configured defaults as the Red Hat type distros do. If you were to just do sudo user add frank on a Debian Ubuntu machine, frank would have no home directory and would be assigned the wrong default shell. So, to create a user account with user add on a Debian or Ubuntu system, the command will look something like this. Sudo user add -m-d home-frank-s/bin/bash frank. Here's a breakdown of what all this means. -m creates the home directory, -d specifies the home directory, -s specifies Frank's default shell. Without the -s, Debian Ubuntu would assign to Frank the bin sh shell. When you look at the home directories on either a Debian machine or an Ubuntu 20.04 machine, you'll see that they're wide open with execute and grid privileges for everybody. ls-l. As you can see, Frank and I can get into each other's stuff, and no, I don't want Frank getting into my stuff. Each user could change the permissions on his or her own directory, but how many of your users would know how to do that? So let's fix that ourselves. cd/home sudo change mode 700 star. Let's see what we have now. ls-l. That looks much better. To change the default permission setting for home directories, open /etc/login.fs for editing. Look for this line, umask 022. Change it to this, umask 077. Now, new users' home directories will get locked down in creation just as they do with Red Hat and its offspring. On Ubuntu 22.04, things are a bit different. Ubuntu developers have finally realized the user's home directory should be locked down by default. So the home_mode setting in an Ubuntu 22.04 login.dofs file now looks like this. Home mode 0750. This includes access permissions for users' own personal group, but that's okay. It still effectively means that only the respective owners of the various home directories can get into them. Add user on Debian Ubuntu. The add user utility is an interactive way to create user accounts and passwords with a single command, which is unique to the Debian family of Linux distros. Most of the default settings that are missing from the Debian implementation of user add are already set for add user. On Debian and Ubuntu 20.04, it creates user home directories with a wide open 755 permissions value. Fortunately, that's easy to change. We'll see how just a bit. On Ubuntu 22.04, it creates properly locked down home directories with a restricted 750 permissions value. You'll see that setting in the /etc/adduser.conf file in the vicinity of line 56, the_mode equals 750. As I mentioned before, that will be set to a 755 value in Ubuntu 20.04. Just change that value to 750 to lock down the new home directories. Although adduser is handy for just casual creation of user accounts, it doesn't offer the flexibility of user add, and it isn't suitable for use in shell scripting. One thing that adduser can do that adduser can't is to automatically encrypt the user's home directory as you create the account. To make it work, you'll first have to install the encryptfs-utils package. So to create an account with an encrypted home directory for Cleopatra, you'll do the following. Sudo apt install encryptfs-utils. We'll look at the whole encryption thing in more detail when we get to the encryption chapter. Hands-on lab for creating an encrypted home directory with adduser. For this lab, we'll be working with the adduser utility on Ubuntu 22.04 VM. Install the encryptfs-utils package, sudo apt install encryptfs-utils. Create a user account with an encrypted home directory for Cleopatra and then view the results. Sudo adduser --encrypt-home Cleopatra ls-l/home. Log in as Cleopatra and run the encryptfs unwrap passphrase command. su-Cleopatra encryptfs-unwrap-passphrase exit. Note that some of the information that adduser asks for is optional, and you can just hit the enter key for those items. Enforcing strong password criteria. You wouldn't think that a benign-sounding topic such as strong password criteria would be so controversial, but it is. The controversial wisdom that you've undoubtedly heard for your entire computer career says, make passwords of a certain minimum length. Make passwords that consist of a combination of uppercase letters, lowercase letters, numbers, and special characters. Ensure that passwords don't contain any words that are found in a directory or that are based on the user's own personal data. Force users to change their passwords on a regular basis. But using your favorite search engine, you'll see that different experts disagree on the details of these criteria. For example, you'll see disagreements about whether passwords should be changed every 30, 60, or 90 days, disagreements about whether all 4 types of characters need to be in a password, and even disagreements on what the minimum length of a password should be. The most interesting controversy of all comes from, of all places, the guy who invented the preceding criteria to begin with. He now says that it's all bunk and regrets having come up with it. He now says that we should be using passphrases that are long yet easy to remember. He also says that they should be changed only if they have been breached. Bill Burr, the former National Institute of Standards and Technology (NIST) engineer who created the strong password criteria that I outlined earlier, shared his thoughts about why he now disavows his own work. And since the initial edition of this book was published, NIST has come to agree with Bill Burr. They have now changed the password implementation criteria to match Mr. Burr's recommendations. You can read it about that. However, having said all that, there is the reality that many organizations are still wedded to the idea of using complex passwords that regularly expired, and you'll have to abide by their rules if you can't convince them otherwise. And besides, if you are using traditional passwords, you do want them to be strong enough to resist any sort of password attacks. So now let's take a look at the mechanisms of enforcing strong password criteria in a Linux system. I have to confess that I had never before thought to try creating a passphrase to use in place of a password in a Linux system. So I just tried it on my CentOS virtual machine to see if it would work. I created an account for Maggie, my black and white tuxedo kitty. For her password, I entered the passphrase, "I like other kitty cats." You may think, oh, that's terrible, this doesn't meet any complexity criteria and it uses dictionary words, how is that secure? But the fact that it's a phrase with distinct words separated by blank spaces does make it secure and very difficult to brute force. Now in real life, I would never create a passphrase that expresses my love for cats, because it's not hard to find out that I really do love cats. Rather, I would choose a passphrase about some more obscure part of my life that nobody but me knows about. In any case, there are two advantages of passphrases over passwords. They're more difficult to crack than traditional passwords, yet they're easier for users to remember. For extra security though, don't create passphrases about a fact of your life that everybody knows about. Installing and configuring PW Quality. We'll be using the PW Quality module for the Pluggable Authentication module, PAM. This is a newer technology that has replaced the old cracklet module. On any Red Hat 7 or newer type of system, and on SUSE and OpenSUSE, PW Quality is installed by default, even if you do a minimal installation. If you cd into the /etc/pam.d directory, you can do a grep operation to check that the PAM configuration files are already set up. Retry equals 3 means that a user will only have three tries to get the password right when logging into the system. On Debian and Ubuntu, you'll need to install PW Quality yourself like this. Sudo apt install libpam-pw quality. The rest of the procedure is the same for all of our operating systems and consists of just editing the /etc/security/pwquality.conf file. When you open this file in your text editor, you'll see that everything is commented out, which means that no password complexity criteria are in effect. You also see that it's very well documented because every setting had its own explanatory comment. You can set password complexity criteria however you want just by uncommenting the appropriate lines and setting the appropriate values. Let's take a look at just one setting. The minimum length setting works on a credit system. This means that for every different type of character class in the password, the minimum required password length will be reduced by 1 character. For example, let's set minlen to a value of 19 and try to assign Caitlin the password of turkey lips. Minlen equals 19. Sudo password Caitlin, change the password for user Caitlin, new password, bad password. The password is shorter than 18 characters, retype new password. Because lowercase characters in turkey lips count as credit for one type of character class, we're only required to have 18 characters instead of 19. If we try this again, which turkey lips we'll get? Sudo password Caitlin, change the password for user Caitlin, new password, bad password. The password is shorter than 17 characters, retype new password. This time the uppercase T and the uppercase L counts as a second character class, so we only need to have 17 characters in the password. Just below the middle length line, you'll see the credit lines. Let's say that you don't want lowercase letters to count toward your credits. You would find this line, L credit equals 1. Uncomment it and change the 1 to a 0. L credit equals 0. Then try assigning Caitlin turkey lips as a password. Sudo password Caitlin, change the new password for user Caitlin, new password, bad password, the password shorter than 19 characters, retype new password. This time the PW Quality really does want 19 characters. If we set a credit value to something higher than 1, we would get credit for multiple characters of the same class type up to that value. We can also set the credit values to negative numbers in order to require a certain number of character types in the password. For example, we could have this: the credit equals -3. This would require at least 3 digits in the password. However, it's rarely a bad idea to use this feature, because someone who's doing a password attack would soon find the patterns that you require, which would help the attacker to direct the attack more precisely. If you need to require that a password has multiple character types, it would be better to use the min class parameter. Min class equals 3. It's already set to a value of 3, which would require characters from 3 different classes. To use this value, all you have to do is to remove the comment symbol. The rest of the parameters is in pwquality.conf work pretty much the same way, and each one has a well-written comment to explain what it does. If you use your pseudo privilege to set someone else's password, the system will complain if you create a password that doesn't meet the complexity criteria, but it will let you do it. If a normal user were to try to change his or her own password without pseudo privileges, the system would not allow a password that doesn't meet the complexity criteria. And some lab for setting a password complexity criteria. For this lab, you can use either CentOS or Linux or Ubuntu virtual machine as desired. The only difference is that you won't perform step 1 for either CentOS or Linux. For Ubuntu only, install the pem-pwquality package, sudo apt install the pem-pwquality. Open the etc security pwquality conf file in your preferred text editor. Remove the comment symbol from in front of this min line and change the value to 19. It should now look like this: min len equals 19. Save the file and exit the editor. Create a user account for Goldie and attempt to assign her the passwords turkeylibs, and turkey93libs. Note the change in each warning message. In the pwquality.conf file, comment out the min line, uncomment the min class line and the max class repeat line. Change the max class repeat value to 5. The lines should now look like this: min class equals 5, max class repeat equals 5. Save the file and exit the text editor. Try assigning various passwords that don't meet the complexity criteria that you've set to Goldie's accounts and view the results. In the etc login.defs file on your CentOS 7 machine, you'll see the line pass_min_length 5. Supposedly, this is to set the minimum password length, when in reality, pwquality overwrites it. So, you could set this value to anything at all and it would have no effect. Note that the pass_min_length parameter is no longer supported on RHEL 8-9 type distros. Setting and enforcing password and account expiration. Something you never want is to have unused user accounts remain active. There have been incidents when an administrator sets up user accounts for temporary usage, such as for a conference, and then just forgot about them after the accounts were no longer needed. Another example would be if a company were to hire contract workers whose contract expires on a specific date. Allowing those accounts to remain active and accessible after the temporary employees leave the company would be a huge security problem. In cases like these, you want a way to ensure that temporary user accounts aren't forgotten about when they're no longer needed. If an employee subscribes to the conventional wisdom that users should change the passwords on a regular basis, then you'll also want to ensure that it gets done. Password expiration data and account expiration data are two different things. They can be set either separately or together. When someone's password expires, he or she can change it and everything will be all good. If somebody's account expires, only someone with the proper admin privileges can unlock it. To get started, take a look at the expiry data for your own account. Note that you won't need pseudo privileges to look at your own data, but you'll still need to specify your own username. CHAGE-L dummy. You can see here that no expiration data has been set. Everything here is set according to the out-of-the-box system default values. Other than the obvious items, here's a breakdown of what you see. Password inactive. If this was set to a positive number, I would have that many days to change an expired password before the system will lock out my account. Minimum number of days between the password change. Because this is set to 0, I can change my password as often as I like. If it was set to a positive number, I would have to wait that number of days after changing my password before I could change it again. Maximum number of days between the password change. This is set to the default value of 99999, meaning that my password will never expired. Number of days of warning before password expires. Default value is 7, but that's rather meaningless when the password is set to never expire. With a CHAGE utility, you can either set password and account expiration data for other users too, or use the -L option to view expiration data. Any unprivileged user can use change -L without sudo to view his or her own data. To either set data or use someone else's data, you need sudo. We'll take a closer look at change a bit later. Before we look at how to change expiration data, let's first look at where the default settings are stored. We'll first look at the etc login defs file. Here are the three relevant lines. pass_max_days 99999, pass_min_days 0, pass_1_age 7. You can edit these values to fit your organization's needs. For example, changing pass_max_days to a value of 30 would cause all new user passwords from that point on to have 30-day expiration data. By the way, setting the default password expiry data in login.devs works for all of the Linux distros we're using. Configuring default expiry data for user add for Red Hat type systems only. The etc default user add file has the rest of the default settings. In this case, we'll look at the one from the Linux client machine. Ubuntu also has the user add configuration file, but it doesn't work. No matter how you configure it, the Ubuntu version of user add just won't read it. So the write-up about this file only applies to Red Hat type systems. The expire line sets the default expiration date for new user accounts. By default, there is no default expiration date. Inactive equals -1 means that user accounts won't be automatically logged out after the user's passwords expire. If we set this to a positive number, then any new users will have that many days to change that expired password before their account gets locked. To change the defaults in the user add file, you can either hand edit the file or use user add-d with the appropriate option switch for the item that you want to change. For example, to set the default expiration date of December 31, 2025, the command would be as follows: sudo user add-d-e 2025-12-31. To see the new configuration, you can either open the user add file or just do sudo user add-d. Sudo user add-d. You've now set it so that any new user accounts that get created will have the same expiration date. You can do the same thing with either the inactive setting or the shell setting. Sudo user add-d-s/bin/csh.
Now, any new user accounts that get created will have the ZSH shell set as a default shell and will have to have expired passwords changed within 5 days to prevent this account from being automatically locked out. User add doesn't do any safety checks to ensure that the default shell that you have assigned is installed on the system. In our case, ZSH isn't installed, but user add will still allow you to create accounts with ZSH as the default shell. So, just how useful is this user add configuration feature in real life? Probably not that much, unless you need to create a whole bunch of user accounts at once with the same settings. Even so, a savvy admin would just automate the process with a shell script rather than messing around with this configuration file. Setting expiry data on a per account basis with user add and user mod. You might find it useful to set the default password expiry data in login.devs, but you probably won't find it too useful to configure the user add configuration file. Rarely. What are the chances that you'll want to create all user accounts with the same account expiration date? Setting password expiry data in login.devs is more useful because you'll just be saying that you want new passwords to expire within a certain number of days, rather than to have them all expire on a specific date. Most likely, you'll want to set account expiry data on a per account basis, depending on whether you know that the accounts will no longer be needed on a specific date. There are 3 ways that you can do this. The user add with the appropriate option switches to set expiry data as you create the accounts. If you need to create a whole bunch of accounts at once with the same expiry data, you can automate the process with a shell script. Use user mod to modify expiry data on existing accounts. The beautiful thing about user mod is that it uses the same option switches as user add. The change to modify expiry data on existing accounts. This one uses a whole different set of option switches. You can use user add and user mod to set account expiry data, but not to set password expiry data. The only 2 option switches that affect account expiry data are as follows. -E. Use this to set an expiration date for the account in the form year, month, day. -F. Use this to set the number of days after the user's password expires that you want for his or her account to get locked out. Let's say that you want to create an account for Charlie that will expire at the end of 2025. On a Red Hat type machine, you could enter this: sudo user add-e 2025-12.31 Charlie. On a non-Red Hat type machine, you'd have to add the option switches that create a home directory and assign the correct default shell. Sudo user add-m-d/home/charlie-s/bin/bash-e 2025-12.31 Charlie. Use change-l to verify what you've entered. Sudo change-l Charlie. Now, let's say that Charlie's contract has been extended and you need to change his account expiration to the end of January 2026. You'll use usermod the same way on any Linux distro. Sudo usermod-e 2026-0131 Charlie. Again, verify that everything is correct with change-l. Sudo change-l Charlie. Optionally, you can set the number of days before an account with an expired password would get locked out. Sudo usermod-f5 Charlie. But if you were to do that now, you wouldn't see any difference in the change-l output because we still haven't set expiration data for Charlie's password. Setting expiry data on a per account basis would change. You will only use change to modify existing accounts, and you will use it for setting either an account expiration or a password expiration. Here are the relevant option switches. Option explanation -d. If you use the -d0 option on someone's account, you'll force the user to change his or her password on their next login. -e. This is relevant to lowercase -e for user add or user mod. It sets the expiration date for the user account. -i. This is equivalent to -f for user add or user mod. It sets the number of days before an account with an expired password will be locked out. -m. This sets the minimum number of days between password changes. In other words, if Charlie changes his password today, the -m5 option would force him to wait 5 days before he can change his password again. -m. This sets the maximum number of days before the password expires. Be aware, though, that if Charlie last set his password 89 days ago, using a -m90 option on his account will cause his password to expire tomorrow, not 90 days from now. -w. This will set the number of warning days for passwords that are about to expire. You can set just one of these data items at a time, or you can set them all at once.
In fact, to avoid frustrating you with a different demo for each individual item, let's set them all at once except for -d0, and then we'll see what we've got. Sudo change-e 2026-0228-i4-m3-m90-w4 Charlie. All the expiration data have now been set. For our final example, let's say that you've just created a new account for Samsung and you want to force him to change his password the first time he logs in. There are two ways to do that. Either way, you would do it after you've set his password initially using one of these two commands: sudo change-d0 Samsung or sudo password-e Samsung. Next, we will go through a hands-on lab. Hands-on lab for setting account and password expiry data. In this lab, you'll create a couple of new user accounts, set expiration data, and view the results. You can do this lab on any of your virtual machines. The only difference will be with the user add commands. On your CentOS or Oma Linux VM, create a user account for Samsung with expiration date of June 30, 2025 and view the results. Sudo user add-e 2025-06-30 Samsung. Sudo change-l Samsung. For Ubuntu, run these commands: sudo user add-m-d/home/samsung-s/bin/bash-e 2025-06-30 Samsung. Sudo change-l Samsung. Use usermod to change Samsung's account expiration date to July 31st, 2025. sudo usermod-e 2035 0731 Samsung sudo change-l Samsung. Assign a password to Samsung's account, then force him to change his password on his first login. Log in as Samsung, change his password, then log in into your own account. Sudo password Samsung, sudo password-a Samsung, sudo change-l Samsung, su-Samsung exit. Use change to save a 5-day waiting period for changing password, a password expiration period of 90 days, an inactivity period of 2 days, and a warning period of 5 days. Sudo change-m5-m90-i2-w5 Samsung sudo change-l Samsung. Keep this account because you will be using it for the lab in the next section. Next, let's see how to prevent brute force attacks. Preventing brute force password attacks. Amazingly enough, this is another topic that engenders a bit of controversy. I mean, nobody denies the wisdom of automatically locking out user accounts that are under attack. The controversial part concerns the number of failed login attempts that we should allow before locking the account. Back in the Stone Age of computing, so long ago that I still had a full head of hair, the early Unix operating systems only allowed users to create a password with a maximum of 8 lowercase letters. So in those days, it was possible for early man to brute force someone else's password just by sitting down at the keyboard and typing in random passwords. That's when the philosophy started of having user accounts that get locked out after only 3 failed login attempts. Nowadays, with strong passwords, or better yet, a strong passphrase, setting a lockout value of 3 failed login attempts will do 3 things. It will unnecessarily frustrate users. It will cause extra work for the help desk personnel. If an account really is under attack, it will lock the account before you had a chance to gather information about the attacker. Setting a locked out value to something more realistic, such as 100 failed login attempts, will still provide good security while still giving you enough time to gather information about the attackers. Just as importantly, you won't cause undue frustration to users and help desk personnel. Anyway, regardless of how many failed login attempts your employer allows you to allow, you'll still need to know how to set it all up. On Red Hat Enterprise Linux 7 type systems and Ubuntu 18.04, you'll do this by configuring the pam_tally2 pam. On RHEL 8.9 type systems and Ubuntu 20.04 22.04, you'll instead configure the pam_faillog pam module. Let's dig in and see how it's done. Configuring the pam_tally2 pam module on CentOS 7. To make this magic work, we relied on our good friend PAM. The pam_tally2 module comes already installed on CentOS 7, but it isn't configured. We'll begin by editing the etc pam.d login file. Figuring out how to configure it is easy because there's an example at the bottom of the pam_tally2 man page. Examples: add the following line to etc pam.d login to lock the account after 4 failed logins. Root account will be locked as well. The accounts will be automatically unlocked after 20 minutes. The module does not have to be called in the account phase because the login calls pam_setcred3 correctly. Auth required pam_security.so, auth required pam_tally2.so, deny equals 4, even deny root unlock time 1200, auth required pam_m.so, auth required pam_unix.so, auth required pam_no-login.so, account required pam_unix.so, password required pam_unix.so, session required pam_limit.so, session required pam_unix.so, session required pam_lastlog.so, now TMP session optional pam_mail.so standard. If you're working with a text-based server, you'll only need to configure the etc pam.d login file. But if you're working with a machine that's running a graphical desktop environment, you'll also need to configure the etc pam.d password.auth and etc pam.d system.auth files. You'll see how to do that when you get to the hands-on lab. In the second line of the example, we see that pam_tally2 is set with the following parameters. Deny equals 4. This means that the user account under attack will get locked out after only 4 failed login attempts. Even deny root. This means that even the root user account will get locked if it's under attack. Unlock time 1200. The account will get automatically unlocked after 1200 seconds or 20 minutes. Now, if you look at the actual login file on your virtual machine, you'll see that it doesn't look exactly like this example login file that's on the man page. That's okay, we'll still make it work. Once you've configured a login file and have had a failed login, you'll see a new file created in the var log directory. You'll view this information from that file with a pamtally2 utility. You can also use pamtally2 to manually unlock a locked account if you don't want to wait for the timeout period. Sudo pam_tally2. Sudo pam_tally2 -- user equals charlie -- reset. Note that after I did the reset on Charlie's account, I received no output from doing another query. Hands-on lab for configuring pam_tally on CentOS 7. Configuring pam_tally2 is super easy because it only requires adding one line to the etc pam.d login, etc.pam.d password.auth, and etc pam.d system.auth files. To make things even easier, you can just copy and paste that line from the example on the pam_tally2 man page. In spite of what I said earlier about bumping the number of failed logins up to 100, we'll keep that number at 4 for now, because I know that you don't want to have to do 100 failed logins in order to demo this. On the CentOS 7 virtual machine, open the etc pam.d login file for editing. Look for the line that invokes the pam_security module. That should be around line 2. Beneath that line, insert this line. Auth require pam_tally.so, deny equals 4, even_deny_root, unlock_time equals 1200. Save the file and exit the editor. Place the same line at the top of the etc pam.d password.auth and etc pam.d system.auth files, just above the first auth required line. The comment at the top of these files says to not hand edit them because running auth config will destroy the edits. Unfortunately, you have to hand edit them because auth config won't configure this for you. For this step, you need to log out of your own account because pamtally2 doesn't work with su. So log out, and while purposely using the wrong password, attempt to log in to the Samsung account that you created in the previous lab. Keep doing that until you see a message saying that the account is locked. Note that when the deny file is set to 4, it will actually take 5 failed login attempts to log Samsung out. Log back into your own user account, run this command, and note the output, sudo pam_tally2. For this step, you'll simulate that you're a help desk worker, and Samsung has just called a request that you unlock his account. After verifying that you really are talking to the real Samsung, enter the following 2 commands. Sudo pam_tally2 -- user equals Samsung -- reset sudo pam_tally2. Now that you've seen how this works, open the etc pam.d login file for editing. Change the deny equals parameter from 4 to 100 and save the file. This will make your configuration a bit more realistic in terms of modern security philosophy. Next, let's look at configuring pam_faillog on our Alma Linux machines. Configuring pam_faillog on Alma Linux 8.9. The pam faillog module is already installed on any Red Hat Enterprise Linux 8 or RHEL 9 type of Linux distro, since the basic concepts of pam faillog are pretty much the same as they are for pamtally2. We'll dispense with the preliminary explanations and jump right to the hands-on procedure. Hands-on lab for configuring pam faillog on Alma Linux 8 or Alma Linux 9. Although you can enable and configure pam faillog by hand editing the pam configuration files, the RHEL distros provide an easier method which is called auth select. Note that this procedure works exactly the same for either text mode or GUI type machine. On either an Alma Linux 8 or Alma Linux 9 VM, view the available auth select profiles by doing sudo auth select list. For now, at least, we're only dealing with local users, so we'll use the minimal profile. View the features of this profile like this: sudo auth select list -features minimal. Note that there are a lot of included features, but we are only interested in the will faillog feature. Enable the minimum profile like this: sudo auth select minimal -false. After enabling a profile, we can now enable the pam_faillog module like this: sudo auth select enable -b feature with -faillog. In the etc security directory, open the faillock.conf file in your favorite text editor. Look at these 4 lines. Silent, deny equals 3. Unlock time equals 600, even deny root. Remove the preceding comment symbols from all 4 lines and save the file. Create user accounts for Vicky by doing sudo user add Vicky sudo password Vicky. Open another terminal and have Vicky deliberately make 3 failed login attempts. View the results in your own terminal, like this. Sudo faillock. Then, before the timer expires, have Vicky try to log in again with her own correct password. After the 10-minute timer expires, have Vicky try to log in with the correct password. Have the user log out, then have the user again deliberately make 3 failed login attempts. This time reset the user's accounts before the timer expires, like this, sudo faillock --reset --user Vicky. That's it for this lab. Doing this on Ubuntu is a bit different, so let's now look at that. Configuring pum_faillock on Ubuntu 20.4 and Ubuntu 22.4. Sadly, the auth-select utility isn't available for Ubuntu, so we'll just have to hand edit the PAM configuration files. Here's the procedure. Hands-on lab for configuring pam_faillock on Ubuntu 20.04 and Ubuntu 22.04. Open an etc pam.d common auth file in your favorite text editor. At the top of the file, insert these 2 lines. Auth require pam_faillock.so, pre-auth silent auth require pam_faillock.so, auth fail. Open the etc pam.d common account file in your text editor. At the bottom of the file, add this line, account required pam_faillock.so. Configure the etc security faillock.conf file the same way that I showed you in step 5 of the preceding lab for all Linux. Test the setup as outlined in steps 6 through 8 of the preceding Alma Linux lab. And that's all there is to it. Next, let's look at how to manually lock a user's account. Locking user accounts. Okay, you've just seen how to have Linux automatically lock user accounts that are under attack. There will also be times when you'll want to manually lock out user accounts. Let's look at a few examples. When a user goes on vacation and you want to ensure that nobody monkeys around with that user's account when he or she is gone. When a user is under investigation for questionable activities. When a user leaves the company. With regard to the last point, you may be asking yourself, why can't we just delete the accounts of people who are no longer working there? And you certainly can easily enough. However, before you do so, you need to check with your local laws to make sure that you don't get yourself into deep trouble. Here in the United States, for example, we have the Sarbanes-Oxley law, which restrict what files publicly traded companies can delete from their computers. If you were to delete a user account along with that user's home directory and mails pool, you might be running a full of Sarbanes-Oxley or whatever you may have as the equivalent law in your own home country. Anyway, there are 2 utilities you can use to temporarily lock a user account, usermod and password. In apparent contradiction to what I just said, at some point you will need to remove inactive user accounts. That's because malicious actors can use an inactive account to perform their dirty deeds, especially if that inactive account has had any sort of administrative privileges. But when you do remove the accounts, make sure that you do so in accordance with local laws and with company policy. In fact, your best bet is to ensure that your organization has written guidelines for removing inactive user accounts in its change management procedures. Using usermod to lock a user account. Let's say that Caitlin has gone on maternity leave and will be gone for several weeks. We can lock her account by doing sudo usermod-l Caitlin. When you look at Caitlin's entry in the etc shadow file, you'll now see an exclamation point in front of her password hash like this. The exclamation point prevents the system from reading her password hash, which effectively locks her out of the system. To unlock her account, just do this. Sudo usermod-u Caitlin. You'll see that the exclamation point has been removed so that she can now log into her account. Using password to lock user accounts. You could also lock Caitlin's account like this. Sudo password-l Caitlin. This does the same job as usermod-l, but in a slightly different manner. For one thing, password-l will give you some feedback about what's going on, whereas usermod-l gives you no feedback at all. On Ubuntu, this feedback looks like this. Sudo password-l Caitlin. On CentOS on Alma Linux, the feedback looks like this. Sudo password -l Caitlin. Also, on a CentOS or all Linux machine, you'll see that password-l places 2 exclamation points in front of the password hash instead of just 1. Either way, the effect is the same. To unlock Caitlin's account, just do this, sudo password-u Caitlin. In versions of Red Hat or CentOS prior to version 7, usermod-u would remove only one of the exclamation points that password-l places in front of the shadow file password hash, thereby leaving the account still locked. No big deal though, because running usermod-u again would remove the second exclamation point. Ever since the introduction of the Red Hat Enterprise Linux 7 type distros, this has been fixed. The password-l command still places 2 exclamation points in the shadow file, but usermod-u now removes both of them. That's a shame, really, because it ruined a perfectly good demo that I like to do for my students. Locking the root user account. The cloud is big business nowadays, and it's now quite common to rent a virtual private server from companies such as Rackspace, DigitalOcean, or Microsoft Azure. These can serve a variety of purposes. You can run your own website while you install your own server software instead of letting a hosting service do it. You can set up a web-based app for other people to access. Recently, I saw a YouTube demo on a crypto mining channel that showed how to set up a proof-of-stake masternode in a rented virtual private server. One thing that most of these cloud services have in common is that when you first set up your account and the provider sets up a virtual machine for you, they'll have you log in to the root user account. It even happens with Ubuntu, even though the root account is disabled on a local installation of Ubuntu. I know that there are some folks who just keep logging in to the root account of these cloud-based servers and think nothing of it, but that's really a horrible idea. There are botnets, such as the Hail Mary botnet, that continuously scan the internet for servers that have their secure shell port exposed to the internet. When the botnets find one, they'll do a brute force password attack against the root user account of that server. And yes, the botnets sometimes are successful at breaking in, especially if the root account is set with a weak password. So the first thing that you want to do when you set up a cloud-based server is to create a normal user account for yourself and set it up with full sudo privileges. Then log out of the root user accounts, log into your new user accounts, and do this: sudo password-l root. I mean, really, why take the chance of getting your root account compromised? Setting up security banners. Something that you really don't want is to have a login banner that says something to the effect of "Welcome to our network." I say that because quite a few years ago, I attended a mentored SANS course on incident handling. Our instructor told us a story about how a company took the suspected network intruder to court only to get the case thrown out. The reason? The alleged intruder said, "Well, I saw the message that said welcome to the network, so I thought I really was welcome there." So, yeah, supposedly that was enough to get the case thrown out. A few years later, I related that story to the students in one of my Linux admin classes. One student said, "That makes no sense. We all have welcome mats at our front doors, but that doesn't mean that burgers are welcome to come in." I have to confess that he had a good point, and I now have to wonder about the veracity of the story. At any rate, just to be on the safe side, you do want to set up login messages that make it clear that only authorized users are allowed to access the system. Using the MOTD file, the etc/moth file will present a message banner to anyone who logs into a system through secure shell. On your CentOS or OMA Linux machine, an empty moth file is already there. On your Ubuntu machine, the MOTD file isn't there, but it's a simple matter to create one. Either way, open the file in your text editor and create your message. Save the file and test it by remotely logging in through secure shell. You should see something like this. MOTD stands for Message of the Day. Ubuntu comes with a dynamic MOTD system that displays messages from Ubuntu's parent company and messages about the operating system. When you create a new MOTD file in the etc directory, whatever message you put in will show up at the end of a dynamic output like so. The warning, authorized users only line is what I place into the etc MOTD file. Using the issue file. The issue file, also found in the etc directory, shows the message on the local terminal just above the login prompt. A default issue file will just contain a macro code that shows information about the machine. Here's an example from an Ubuntu machine. On a Red Hat type machine, it will look like this. On an Ubuntu machine, the banner will look something like this. Figure 3.1, the issue file banner. On a Red Hat type machine, it will look something like this. Figure 3.2, a default CentOS issue file banner. You could put a security message in the issue file and it would show up after a reboot. Figure 3.3, a modified CentOS issue file banner. In reality, is there really any point in placing a security message in the issue file? If your servers are properly locked away in a server room with controlled access, then probably not. For desktop machines that are out in the open, this would be more useful. Using the issue.net file. Just don't. It's for telnet logins, and anyone who has telnet enabled on their service is seriously screwing up. However, for some strange reason, the issue.net file still hangs around in the etc directory. Detecting compromised passwords. Yes, dear hearts, the bad guys do have extensive dictionaries of passwords that are either commonly used or have been compromised. One of the most effective ways of brute forcing passwords is to use these dictionaries to perform a dictionary attack. This is when the passwords cracking tool reads passwords from a specified dictionary and tries each one until either the list has been exhausted or the attack is successful. So how do you know if your password is on one of those lists? Easy, just use one of the online services that will check your password for you. One popular site is Have I Been Pwned, which you can see here. Figure 3.4 Have I Been Pwned site. You can get to Have I Been Pwned here, haveibeenpwned.com. All you really have to do is to type in your password and the service will show if it's on any list of compromised passwords. But think about it. Do you really want to send your production password to somebody's website? Yeah, I thought not. Instead, let's just send a hash value of the password. Better yet, let's just send enough of the hash to allow the site to find the password in its database, but not so much that they can figure out what your exact password is. We'll do that by using the Have I Been Pwned application programming interface, API. To demonstrate the basic principle, let's use curl along with the API to see a list of password hashes that have 21BD1 as part of their values. You can do this on any of your virtual machines. I'll just do it on the Fedora workstation that I'm currently using to type this. Just run this, curl https://api.pwnedpasswords.com/range/21bd1. You're going to get a lot of output like this, so I'll just show the first few lines. Let's pipe in this into wc-l, a handy counting utility, to see how many matching results we found. According to this, we found 526 matches, but that's not very useful, so let's fancy things up just a bit. We'll do that by creating the pwnedpasswords.sh shell script, which looks like this. Okay, I can't try to turn you into a shell scripting guru at the moment, but there's a simplified explanation. Candidate password equals $1. This requires you to enter the passwords that you want to check when you invoke the script. Full hash, prefix, suffix. These lines calculate the SHA-1 hash value of the password and then extract just the portions of the hash that we want to send to the password checking service. If curl, we wrap up with an if-then-else structure that sends the selected portions of the password hash to the checking service and then tells us whether or not the password has been compromised. After saving the file, add the executable privilege for the user like so. chmod u+x pwnedpasswords.sh. Now let's see if Turkey Lips, my all-time favorite password, has been compromised. /pwnedpasswords.sh Turkey Lips. Yeah, it's been compromised, alright. So I reckon that I don't want to use that for a production password. Now let's try it again, except with a random 2-digit number tacked on at the end. Well, it says that this one is okay. Still though, you probably don't want to use such a simple permutation of a password that's known to have been compromised. I'd like to take credit for the shell script that I've presented here, but I can't. That was a creation of my buddy, Leo Dorendorf of the former VDOO Internet of Things security company, which has since been acquired by JFrog. I've reproduced the script here with his kind permission. If you're interested in security solutions for your Internet of Things set devices, you can check them out here. Full disclosure, the VDOO JFrog company has been one of my clients. Now, having said all of this, I still need to remind you that a passphrase is still better than a password. Not only is a password harder to crack, it's also much less likely to be on anyone's list of compromised credentials. Hands-on lab for detecting compromised passwords. In this lab, you'll use the Pwned Passwords API in order to check your own passwords. Use the code to see how many passwords there are with the 21BT1 string in their password hashes. Curl https://api.pwnpasswords.com/range/21BT1. In the home directory of any of your Linux virtual machines, create the pwn password as a script with the following content. Add the executable permission to the script. Change mod u+x pwnpasswords.sh. Run the script specifying turkeylibs as a password. /pwnpasswords.sh turkeylibs. Repeat step 4 as many times as you like using a different password each time. The user management techniques that we've looked at so far work great on a small number of computers, but what if you're working in a large enterprise? We'll look at that next. Understanding centralized user management.
In an enterprise setting, you'll often have hundreds or thousands of users and computers that you need to manage. So, logging into each network server or each user's workstation to perform the procedures that we've just outlined would be quite unworkable. But do bear in mind that you still need those skills. What we need is a way to manage computers and users from one central location. Space doesn't permit me to give the complete details about the various methods for doing this. So for now, we'll just have to settle for a high-level overview. Microsoft Active Directory.
I'm not exactly a huge fan of either Windows or Microsoft, but when it comes to Active Directory, I have to give credit where it's due. It's a pretty slick product that vastly simplifies the management of very large enterprise networks. And yes, it is possible to add Unix, Linux computers and their users to an Active Directory domain. I've been keeping a dark secret, and I hope that you won't hate me for it. Before I got into Linux, I obtained my MCSE certification for Windows Server 2003. Mostly, my clients work with nothing but Linux computers, but I occasionally do need to use my MCSE skills. Several years ago, a former client needed me to set up a Linux-based NatGeo server as part of a Windows Server 2008 domain, so that its users would be authenticated by Active Directory. It took me a while to get it figured out, but I finally did, and my client was happy. Unless you wear many hats, as I sometimes have to do, you, as a Linux administrator, probably won't need to learn how to use Active Directory. Most likely, you'll just tell the Windows Server administrators that you need what you need and let them take care of it. I know, you've been chomping at the bit to see what we can do with a Linux server. So, here goes. Samba on Linux. Samba is a Unix Linux daemon that can serve three purposes. Its primary purpose is to share directories from a Unix Linux server with Windows workstations. The directories show up in Windows File Explorer as if they were being shared from other Windows machines. It can also be set up as a network print server. It can also be set up as a Windows domain controller. You can install Samba version 3 on a Linux server and set it up to act as an old-style Windows NT domain controller. It's a rather complex procedure and it takes a while. Once it's done, you can join both Linux and Windows machines to the domain and use the normal Windows user management utilities to manage users and groups. One of the Linux community's holy grails was to figure out how to emulate Active Directory on a Linux server. That became something of a reality just a few years ago with the introduction of Samba version 4. But setting it up is a very complex procedure and isn't something that you'll likely enjoy doing. So perhaps we should keep searching for something even better. Free IPA identity managed on Red Hat Enterprise Linux type distros. Several years ago, the Red Hat company introduced free IPA as a set of packages for Fedora. Why Fedora? It's because they wanted to give a thorough test on Fedora before making it available for actual production networks. It's now available for Red Hat Enterprise Linux 7 through RHEL 9 and all of the offspring, including CentOS and Alma Linux. This is what IPA stands for: Identity Policy Audit. It's something of an answer to Microsoft Active Directory, but still isn't a complete one. It does some cool stuff, but it's very much a work in progress. The coolest part about it is how simple it is to install and set up. All it really takes is installing the packages from the normal repositories, opening the proper firewall ports, and then running a setup script. Then, you're all set to start adding users and computers to the new domain via free IPA's web interface. Here, I'm adding Cleopatra, my grey and white tabby kitty. Figure 3.5, adding the user via free IPA. Although you can add Windows machines to a free IPA domain, it's not recommended, but starting with Red Hat Enterprise Linux CentOS 7.1, you can use free IPA to create cross-domain trust with an Active Directory domain. The official name of this program is free IPA, but for some strange reason, the Red Hat fork refused to mention that name in their documentation. They always just refer to it as either Identity Manage or IDM. That's pretty much it for the user management topic. Let's summarize and then move on to the next chapter. Summary. In this chapter, we look at how to lock down users' home directories, how to enforce strong password policies, and how to enforce account and password expansion policies. Then, we talked about a way to prevent brute force and password attacks, how to manually lock out user accounts, how to set up security banners, and how to check for compromised passwords. We wrap things up with a brief overview of central usage management systems. In the next chapter, we'll look at how to work with various firewall utilities. I'll see you there. Questions. In which file would you configure complex password criteria? When using the user-add utility on a RHEL 7 type machine, what should the umask setting be in the etc login.defs file? When using an add user utility on an Ubuntu 20.04 machine, how would you configure the etc adduser.conf file so that new users' home directories will prevent other users from accessing them? What change did the National Institute for Standards and Technology recently make to its recommended password policy? Which three of the following utilities can you use to set out user account expiry data? User add, add user mod, change. Why might you want to lock out the user account of a former employee rather than delete it? It's easier to lock an account than it is to delete it. It takes too long to delete an account. It's not possible to delete a user account. Deleting a user account along with the user's files and mail pool might get you into trouble with the law. You've just created a user account for Samsung, and you now want to enforce him to change his password the first time he logs in. Which two of the following commands will do that? Sudo shage-d 0 Samsung, sudo password-d o Samsung, sudo shage-e Samsung, sudo password-e Samsung. Which one of the following is an advantage that the add user utility has over the traditional user add utility? Add user can be used in shell script. Add user is available for all Linux distributions. Add user has an option that allows you to encrypt a user's home directory as you create the user account. Add user is also available for Unix and BSD. In the newest Linux distributions, what is the name of the PAM module that you can use to enforce strong passwords? Craplib, passwords, secure, PW quality. Further reading. You might not need complex alphanumeric passwords after all. The new NIST guidelines, we had it all wrong before. Linux user management, the free IPA project homepage, RHEL 9 documentation, scroll down to the identity management section. Red Hat Enterprise Linux 8 documentation, scroll down to the identity management section. RHEL 7 documentation, scroll down to the identity management section. PAM fail log user account after X failed attempts. Answers: etc security pwquality.conf 077 changed the dir mode value to dir mode 750. They abandoned their old philosophy about password complexity and password expirations. A, C, and D. D. A and D. C. D.